Hello, everyone. My name is Tiffany Dangleben. We are pleased that you all can join us for this week's lecture in Volume 9 of the No Neuropsychology Didactic Series that brings you lectures from experts in the field covering different topics each week. This series was created by trainees and early career neuropsychologists, including standing members of the No Neuropsychology Board, as well as members of the No Neuropsychology Committee. Before we start our lecture, one of the main goals of No Neuropsychology is to provide free, high-quality didactic content to our audience. Every No Neuropsychology and No Neuroanatomy lecture is available on our YouTube channel. Be sure to check it out, subscribe, and like our lectures to get first access to new content. New to No Neuropsychology is our collaboration with APPCN to bring you learning and discussion questions that are provided with specific lectures content. You can access these on our website and through APPCN. Here are disclaimers for the series. This training is not meant to replace formal education in neuropsychology, and the views of the speakers are their own. Questions can be submitted via the Q&A box on the lower left of your screen, and a recording of today's lecture will be provided on our website and YouTube channel later this week. Now, it is my pleasure to introduce Dr. Carrie McDonald and Dr. Laura Glass-Umfleet for today's lecture titled Towards Open Science Neuropsychology, which will be moderated by Leah Talbert. Dr. Carrie McDonald is a professor of radiation medicine and applied sciences and psychiatry at UC San Diego and is a board-certified clinical neuropsychologist. She is a principal investigator at the UCSD Center for Multimodal Imaging and Genetics and director of the Lab of Cognitive Imaging. Her primary research interests surrounding using advanced multimodal imaging in combination with patient-specific risk and resilience factors to predict post-operative and post-radiation cognitive outcomes in adults with epilepsy and brain tumors. She is also the director of the Neuropsychological Assessment Clinic at the UCSD Morris Cancer Center, where she trains graduate students and postdoctoral fellows in the evaluation of patients with CNS and non-CNS cancers. Dr. McDonald is PI on 3 multi-center R01s from the NINDS and a co-investigator on grants from the NINDS and NCI that use advanced imaging to study cognitive networks in epilepsy and brain tumors. Dr. Glass-Umfleet is an associate professor of neurology. She specializes in the neuropsychological evaluation of adults with neurologic and neurobehavioral disorders, memory disorders, head trauma, and ADHD. Her background includes research focusing on the investigation of various psychometric properties of the Wechsler intellectual scales, performance on selected neuropsychological measures in patient populations such as memory disorders, Parkinson's disease, and multiple sclerosis, and the clinical or psychometric issues related to symptom validity testing. Other research interests include investigating normal versus abnormal aging, as well as developing research that demonstrates the value of neuropsychology. Her work has been presented at national conferences and published in peer-reviewed professional journals. Now I will pass it along to Ms. Leah Talbert.
So excited about this partnership with No Neuropsychology and the Cultural Neuropsychology Council to discuss open science. Open science represents the readily available worldwide access to data and science for future generations to expand on, and acknowledging that fact, it's hard to separate open science from cultural inclusivity. And the mission of the Cultural Neuropsychology Council is to facilitate that paradigm shift to a more culturally centered science, training, and practice of neuropsychology. So To get us started on our discussion, we'll have a brief presentation by Drs. MacDonald and Umfleet. So we can go ahead and get started.
Okay, thank you so much. It's really my pleasure to be here today to have the opportunity to talk to this group about some work that I've been involved in. I'll go ahead and share my slides. All right. How is that? Can you see this?
Yes, we can.
Wonderful, thank you. Okay. And talk about some work that I've had the opportunity to lead called the ENIGMA Epilepsy, and how we operate as a model for sharing data and collaboration. We're not open science in the sense that we have all the data readily available that you can go to a website and download it, but we have done quite a bit internationally to promote global science and open science, and I'll talk about that and where we are these days. So I'll start off by describing ENIGMA, or the Enhancing Neuroimaging and Genetics through Meta-Analysis Consortium, and the model that we currently operate under for data sharing and sharing of neuroimaging tools. And then I'll discuss a little bit about the challenges and the opportunities that are presented to us when we're trying to develop a large international study and consortium. But before I do, I want to back up and explain a little bit about what ENIGMA is. So ENIGMA was actually the brainchild of Paul Thompson. He's a professor up at USC. And he wanted to develop a worldwide network of scientists in genetics, neurology, and psychiatry, with the goal of diversifying science through global aggregation of data. So this, although it's been focused on imaging and genetic, it also includes clinical data. And you can see here we have a very broad geographical footprint. It's not perfect, but includes a lot of sites from around the world. And this was initiated in 2009 under an NIH grant. It was called a Big Data to Knowledge grant that was focused mostly on imaging of psychiatric disorders. But fast forward about 15 years, and since that time, we've grown to over 2,000 members, over 45 countries, and actually produced the largest neuroimaging studies in about 11 brain disorders. And I'll say again, although I'm thinking, or I'll be talking about this through the lens of a neuroimager, a lot of what I'll be talking about today applies to neuropsychological data. And I'll also talk about how we plan to integrate neuropsychological data into our thinking. This group not only includes 32 clinical groups, and ENIGMA Epilepsy operates as one of these clinical groups, but also groups that look at normal aging and development, genetics, and algorithmic development. And many of these tools are now open source. And if you're interested in learning about any of the particular working group, there's this really nice review in human brain mapping that outlines 32 papers of each group and what each group goals are currently. So what is ENIGMA? I mentioned that it's a global collaboration of scientists with 32 working groups focusing on specific psychiatric and neurological disorders. So there's ENIGMA TBI, there's ENIGMA major depressive disorder, schizophrenia, and as I mentioned, I've had the opportunity to lead the ENIGMA Epilepsy group. We're really a framework for harmonized data processing and analysis. And I underline the data processing and analysis piece because it's very difficult to get a group together or a global initiative where everyone agrees to do the imaging exactly the same way from the outset. That's kind of comparable to if we went in and asked every center around the world to give the same neuropsychological tests and use the same normative data. It just wouldn't make sense. So we're focusing more on how we can utilize the outputs of what each center does and harmonize them for the processing and analysis portion. And I want to point out that ENIGMA is really complementary to individual cohort studies. It's not meant to replace what many of us do in our day-to-day practice or NIH grants. Those can answer requisite questions. It's really a way to promote more inclusive research and a global initiative that can include not only research participants or groups, but also non-research groups in clinical settings who want to be involved. So this is ENIGMA Epilepsy. I mentioned that we're one of 23 clinical groups within ENIGMA. And ENIGMA Epilepsy itself has 56 sites from around the world. We are in 18 countries. And our mission is really to advance the understanding of neurobiological processes of different epilepsy syndromes by building a large and diverse data set of imaging, genetic, and clinical demographic information. And you can see here that although we are around the world, it's still very much based in US and in Europe. So we still need to get more broad areas. There are many areas of the map here where we don't have representation yet. So before I tell you kind of how we are currently operating, I have to back up a little bit to explain where we came from. And also this might set a precedent for how you might develop a global initiative. We began at the Royal Society of London in 2015, where the idea of ENIGMA Epilepsy was proposed, and 12 centers developed what's called a Memorandum of Understanding. So this is a document that outlines how we practice and how we work with each other. Over the next several months, 12 additional centers were recruited. So 12 centers joined initially, 12 more recruited and signed the MOU. And I was actually among these centers that got recruited by email, such that by pretty soon after we developed, we had 24 centers worldwide who agreed to contribute over 2,000 data sets of patients with epilepsy and 1,700 healthy controls. We then began meeting on monthly conference calls and then developed our first study, which we decided we sent scripts around. So these are basically scripts in order to generate neuroimaging profiles. We sent them around to each center who had a data analyst off-site, analyze the data according to the process or the scripts that have been sent. And then they sent only the summary statistics back to the central center. So again, this was back in 2015. And in trying to get everyone on board around the world in a quick period of time, all we could aggregate were the summary statistics. So these are actually just case control effect sizes. But with this process, we were able to devise a meta-analysis, which got published in Brain in 2018. Now, I have to back up a little bit to explain, how we got there. That sounds like it was a very easy process, but there was a lot that went into making sure that everyone felt comfortable with the way that their data were being used and analyzed. So the Memorandum of Understanding has been an important document for our consortium. And so this is a document that outlines expectations for membership. We actually encourage and expect active participation among our members. Policies for data sharing that outline not only what will be shared, but how frequently and how we protect data. Process for proposing proposals. So if you're a member of ENIGMA Epilepsy and you have a research idea and you want to utilize the data, how does that happen? Policies for publication and publication credit. That's certainly a very important part. And then in June of 2021, we had to revise our document because of data protection policy that came out of Europe called the General Data Protection Regulation. And for any of you who are involved in or wish to be involved in global initiatives, it's very, very strict data protection rules that we have to operate under. And it required us to adjust our model of data sharing a bit. So what do we expect among our members? When someone joins, they sign the Memorandum of Understanding. I mentioned that all of the projects, we expect group membership, but all projects are in an opt-in basis. So if you're a PI and you submit data to ENIGMA Epilepsy, you can actually opt in or out of any proposal that someone develops. And we wanted to do that for our members because some PIs wanted to retain some ability to control how their data were used, or there may be some projects in which they could not participate. So we gave the PI the ability to retain that right. Members are expected to participate not only in the planning and the analytic strategy, but also to get on calls and review the data and to review manuscripts and approve those manuscripts. And it's important for me to point out at this point that raw neuroimaging or clinical data are not necessarily shared. Some of our colleagues are not able to share that. And so we either have groups who have an image analyst offsite who can process the data and return it to us for projects, or for those centers that don't have the resources or the technological sophistication to do that, they send their data centrally to us at UCSD and we process the data for them. So let me describe the models under which we operate, because there are actually a few. I mentioned the meta-analysis. So that first project that we had, every site retained their own imaging data. They also retained their own clinical data, and this could include neuropsychological data. Then all that was set to the central center were effect sizes. So this got a very, very large group of people on board very quickly, but it wasn't very granular. And of course, we recognized very quickly that we needed to move more towards a mega analytic strategy. And so what this was one in where people still retained the raw data, but summary data were sent to each of the sites. And you can imagine from a neuropsychological perspective, this might be you sending not maybe your item level analysis, but the summary scores that you get out. So maybe your T-scores, and those are going to a coordinating site. And this has been a pretty successful model for us. So this has resulted over the course of the last 5 or 6 years in 11 publications, 2 that are under review. This has been a really great model for us and has really increased our growth in terms of not only people participating, but data sets that we could analyze. But it's also become pretty clear to us moving forward that in order to really do very sophisticated and granular analysis, we have to move towards a raw imaging data centralization. So now what we're doing, not only do we have a model where some groups keep their data off-site if they have an imaging analyst, but most people are taking their imaging data and sending it directly to us. So we retain at UCSD not only the imaging data, but the summary data that includes clinical, and we're moving towards neuropsychological data. And this has become really important in the imaging field because there's a lot of work that's going into machine learning and how we can look at individual images for medical image analysis, only for diagnosis and prediction. But it's really important for us to have a global effort, because the decisions that we can make are only as good and as representative as the data that go into these. This is one of the reasons that a global initiative is so important for us. If we don't have the diversification in the training set or what we're using to develop our algorithms, they'll never be globally applicable. So how do we share data in ENIGMA Epilepsy? It starts off with a data use agreement. So those of you who have been involved in big data initiatives have probably executed data use agreements, material transfer agreements, and these are executed between UCSD, our site, and all of our partners. And then we send a unique link for the imaging data, and a separate link is for the de-identified clinical data. And that's because in order to comply with different regulations, we want to keep our imaging data and pseudo-anonymized MRI data very separate from the clinical data that are set. It's another layer of data privacy. And this gets into some of the imaging, but it does outline different ways in which we treat the imaging to make sure that our data cannot be re-identified. There's a paper, and this applies, again, much more broadly outside of imaging. But as we want to move towards more global sharing and more open sharing of data, we also have to be very mindful of the fact that there are increasing ways of recognizing and re-identifying data that were not necessarily a problem years ago. So when data come into UCSD, one of the things that's very important, and this certainly extends to neuropsychology, is that we have a really structured framework for how we process the data to make it very standardized. And for us, it means converting the data to a very specific imaging format, processing it through very, very specific processing pipelines, so that what we get at the end of the day is something very structured and usable for all of our participants. And this has very quickly resulted in us having access to over or almost 4,000 images, and that also includes clinical information on our participants. So I'm going to back up now and describe just briefly, how does this work if you're part of ENIGMA or part of any large consortium and you want to propose a project? And I'll go through this pretty quickly. If there's a project leader who has a good idea, something they want to do, propose to the group to use the data, they develop an analysis plan. They then send it to myself and my co-PI, who look at it and just make sure that there's no major overlap or that they might not work more efficiently with someone else who may have a similar proposal. We then give them feedback and we circulate the plan to all of the members in the consortium. After we circulate it, the project PI gets on a conference call with the whole group and describes the process or what they want to propose. And then we decide if that project could be done on a meta-analytic basis or if it requires access to the regional or to the raw data. Most of them have required access to more granular data at this point. And so then they contact us for access to the central data. We circulate around a form for everyone, for each group to decide. As I mentioned, each PI can either opt in or out of the proposal. If they opt in, we send the data to the person coordinating the proposal, who then runs the analysis. And then there's a series of steps by which the person presents the data to the group. Publication is circulated to everyone for feedback and for review. Now, if you're looking at this and thinking, wow, this seems like a pretty laborious process, it actually doesn't take that long. You might look at this and say, well, why not just have the data in an open repository? That would seem a much more efficient way of operating. But at this time, there are several reasons that we can't. And the first is the one I have to brought up with GDPR. So as I mentioned, this is the European Privacy and Security Act that regulates how many of our colleagues store, transfer, and share data, both not only within and outside of the European Union. And although it's meant to protect data, it also gives the participant themselves more right. In fact, some in the most strict interpretation, you can only use data if the person has provided informed consent for every single use of the data, which is not practical when you're operating on retrospective data. Perhaps more challenging is that everyone interprets this law differently. And so our colleagues in Germany interpret the law differently than our colleagues in Italy interpret the law. So it's really working with each individual site and country to understand how we can use their data and make sure that we comply with their agencies. Another challenge that's come up is what goes into annotating very large volumes of data for open access. It not only can be costly, but it can be time consuming. And so I'm fortunate to have a full-time data analyst who just spends his entire job is making sure that when data come in, that it's formatted, that it's QC'd correctly, and then we get it in a way that can be used well by our colleagues. And then the last part is really the philosophy under which ENIGMA Epilepsy was developed. When groups joined, it was under an assumption of active participation and collaboration, where projects would be designed that would answer questions specifically about epilepsy. And although, we certainly have moved a little bit more broadly than that, we have to stay true to what our initial members signed. The last part is really fostering that ENIGMA community and cross-disorder comparison. So the way we operate is very similar to the way the other ENIGMA groups operate, so that we can all look not only at findings within ENIGMA or epilepsy, but how our findings within epilepsy translate to those of major depressive disorder and TBI and our other working groups. But although our raw data itself are not shared, what ENIGMA has been really strong at doing is actually sharing tools. So this is one that we're particularly proud of. This is the ENIGMA toolbox, which was developed by Sarah Lariviere and Boris Bernhardt. So using the ENIGMA data, they developed a toolbox where you can upload your imaging data, compare it to that of published ENIGMA Epilepsy or ENIGMA projects, also relate it to gene expression profiles. So this is freely available and for anyone who would like to use it. There's a nice paper describing how this was developed in Nature Methods. In addition, we do have open science tools that you can find. If you look at the ENIGMA GitHub and website, we publish all the protocols that we use, so that, again, if you wanted to replicate something that we had found within ENIGMA Epilepsy, you just have to go to this website, download the protocols, and you can follow all the exact same steps to reproduce the same result. And then this just shows a number of the other methods that have either been developed within ENIGMA or that are used within ENIGMA. Many of these have been developed by our members, or again, the protocols themselves are published for use. I want to spend just the next couple of minutes describing another big data effort that I've been involved in. And I think that this is particularly important as we go into neuropsychology and how this also ties into ENIGMA Epilepsy. I've been fortunate to work with this wonderful global group called the ILEE, or the International League Against Epilepsy Neuropsychology Task Force, and to be able to lead what's called the IC code, or the International Classification for Cognitive Disorders in Epilepsy. And what we have developed is a framework for how we can aggregate large amounts of data on epilepsy and develop a way of looking at the data through a cognitive phenotyping approach. And this goes back again to not dictating that each center use the same tests or the same normative data that we use, but rather looking at the outputs of those data or the profiles that we see and how we can compare those on a global level. And this approach can also be applied not only outside of ENIGMA Epilepsy, but within it. So this just shows within ENIGMA Epilepsy, again, we've kind of surveyed our members to see what neuropsychological data they have. And then you can see over here to the left that we don't have specific tests that we require, but just that groups have the general categories or the general types of tests. And then we would put these into a phenotyping framework that describe the profiles, setting specific impairment cutoffs and criteria for classifying impairment. And I've been very fortunate to work with Bruce Herman and Robin Bush, who have been helping to make this more of an open science initiative. Bruce is writing a paper that describes how to go about classifying patients according to the IC code. And then Robin has been developing a calculator and web portal so that, again, anyone who wants to use this can upload their data, phenotype the outputs, and have access to the IC code methods. So just a quick summary, both ENIGMA Epilepsy and the IC code are providing viable approaches to global collaboration and data and tool sharing, and more on the side of tool sharing at this point. That both of these efforts were really established to unite researchers worldwide and to increase the diversity and the generalizability of our research findings. And that although right now we still work within a consortium where we have to be mindful of each group's regulations, we hope that we'll be able to adjust the models for data sharing as we grow and navigate new avenues in the future. So just a very quick, we are a community and we actively get together at a number of different meetings each year. It's really been a wonderful effort to be not only part of the IC code, but to be part of ENIGMA and to collaborate with this really fantastic, wonderful group of scientists. And on that, I'll stop this time. Thank you.
Thank you so much for that wonderful presentation, Dr. McDonald. Now we'll go ahead and start with Dr. Umfleet.
Yes, that was very well organized, and thank you so much. It'd be hard to follow, but I will do my best. Let's see if I can do this properly. You're going to see hopefully nothing, and then you'll see something soon. Okay. Do you see the screen, like the big screen?
Yes, we can see it.
Okay, good. So I know probably like a year and a half ago, I think I talked about the Neuropsych network, the National Neuropsych Network, and thinking about incorporating technology into clinical practice. And because the worldwide initiative for neuropsychological data sharing, WINS-SIG for short, that's part of the INS, is an extension of the NNN. And then I thought it'd be good to update people about where things are at with NNN and then transition into the WIN-SIG, and what the purpose of that SIG is and how we would love to have more training and student members. So I have no disclosures besides I am funded by the NIMH for the NNN project. I'm the site PI for the Medical College of Wisconsin. And I have other funding, but it's not relevant to this. So an overview of the talk, we're going to do a brief summary of common neuropsych practices and how we need to move toward modernizing what we do. And then also a brief discussion of the National Neuropsych Network, purpose, progress, and next steps. And then move into the INS WIN-SIG. I presented this slide before the last talk, but this is just highlighting that Neuropsych back decades ago, what we do then is pretty much what we do now. And an era of big data, technology, different, like really cool analytic methods, we really need to catch up. And if we don't try to change what we do, try to improve, shorten our services, but without compromising reliability and validity of our measures, then Google and other big tech companies can eventually probably overtake things. So we need to stay at the top and try to lead this because we are experts in this field and we have a lot to contribute versus others who are trying to put something together and it may not be as useful or thought out from a scientific standpoint. So I think about neuropsych of the future. We need to really leverage some translational opportunities to expand brain behavior science with, again, big data, population-based studies, increasing the diversity, the equity in what we do, increasing public awareness of what we do, and methods like community-based participatory research methods, but also really getting out there and outreach is another good method as well. But we need to be stronger at that. And then developing novel delivery systems for neuropsych assessment that can improve our clinical efficiency. And this could include technology, telehealth, web-based assessment methods, the Internet of Things, wearables. There's all sorts of gadgets and cool things and some remote assessments that could be usable for clinical practice and how that's going to inform our clinical practice. And we think about how we're going to do some billing for that. So it's, things are moving in that direction, but it'll be interesting how the practice of neuropsychology, the clinical practice, changes over time. So you want to think about, probably most people have been incorporated into some kind of electronic medical record. We use Epic at my site, and I know a lot of sites are using Epic, but you want to think about how can what we do and with other data that are either routinely clinically collected now or that will become part of clinical practice, including blood-based biomarkers. That's a huge thing, especially in Alzheimer's disease. As that stuff becomes more clinically and readily available, how can we kind of put this dashboard of the future that incorporates behavior, that incorporates neuroimaging, that incorporates different biomarker data to really help us with predicting diagnosis and someone's risk for conversion to symptoms over time. And Bob Bilder and Steve Reese really have spearheaded to try to say, we need a revolution in neuropsychological practice. And they have some nice tables in their publication, which kind of just highlights what we currently do and how in the future what we can do, including some IRT-based methods and other novel psychometric methods, and what advantages that this can have, including efficiency without compromising the test psychometrics. And then being able to get a sense of, further understanding what constructs that we're actually measuring across cultures, across different languages too. And this is just highlighting some, future potentials that we can use with leveraging technology and how that can inform our clinical care. And what we are pretty much currently doing is everyone still, for the most part in clinical practice, are using paper and pencil assessments. Maybe some are starting to incorporate some Pearson measures like Q Interactive or some other things into their clinical practice. But largely we are creatures of habit and people get uncomfortable if you start trying to change those things. Because of our need for our field to really grow in this direction and catch up with modern stage practicing and research, Bob Bilder really spearheaded this initiative, and we all got funding from the NIMH to conduct a multi-center study. So we have 4 sites in the phase 1 with UCLA, UF, and MCW, Emory, so some great folks there. We can't do this work without some brilliancy with biostats core work. Steve Reese is just amazing. Same with Keith Whitteman with their knowledge of IRT methods. And we are interacting with test publishers. Pearson has been just tremendously helpful and not tried to direct us in any way or push their technology. And they really want to do whatever they can to support us, which I can't say the same thing for other test publishers. So over just a little bit over 4 years, we have enrolled over 11,000 adult patients without needing to consent anyone. And because it's just routine clinical practice. So we have incorporated technology across the 4 sites to where we are just using it as part of our routine clinical care. And so we're able to get a waiver of consent, and actually we're going to try to become exempt. And so stay tuned for that. And so we, unfortunately, which is not unique to our study, is that there is an overrepresentation of white, non-Hispanic or Latino individuals. And while their Black or African American enrollment is close to the U.S. Census, there's so much work that needs to be done with that. And we've primarily focused on the tests that are in English. And so phase 2, I'm going to talk about that soon, but we're moving in a direction that really prioritize improvement in the measurement that we use for underrepresented groups. And there's also going to be some new methods to try to increase enrollment of underrepresented groups. And we deposit from the technologies that we use. It's typical clinical assessments that we commonly use. Neuropsychologists seem to practice the same thing. If you look at the Rabin et al. Work, we do a lot of the same measurements. And then even outside, outside of the US, there's still high usage of certain tests, and we'll learn more about that. And sometimes they're interpreted, and we don't really necessarily know if they're measuring the same cognitive construct. For this phase, our inclusion and exclusion criteria is broad. As long as they're an adult, then they're able to, we're taking their data, because it's just what comes into clinics across the different sites. What we really wanted to do, and what we are doing, is create an evidence-based battery selection and starting to use more adaptive test selection. Why do we have to give this really long, ridiculous battery that takes hours? Can we shorten what we do without compromising our diagnostic power? Because a lot of stuff that we do is excellent, but do we need, all 26 items or whatever from a certain subtest, or can we maybe just use 5 and get the same information? And creating a test bed where we can use different item information to then create more computerized adaptive tests where relevant. And then looking at different fixed short forms, doing novel analytic approaches, and then creating a test bed for evidence, enabling future measures to be examined directly for their equivalence or superiority. So we're making more and more progress. I could do an entire talk of the progress that we've made from a research standpoint, but that's not the purpose of this, but that maybe at a later talk we can go into that more. So the technologies that were developed as part of the National Neuropsych Network, it would be the first 2. So there's a structured history protocol for neuropsychology, the SHIP and P. It's a nautical theme, so I apologize if people get annoyed by that. And then you notice with the WinSig, which we'll talk about, that was also in line with this. And then there's the system for the acquisition of item level observations and responses, or SAILOR. So try to keep those in mind. The SHIP and P is more of the clinical interview, and then the SAILOR is putting more kind of like a infrastructure for new measurement, but also commonly used neuropsych measures that Pearson does not own, that we are putting into that platform. And where we started is with the commonly administered tests. And then we're going to start shifting to more novel measurement as things develop, and measurement in different languages. And then Pearson is not one of our technologies, but we are using it because they own a lot of commonly administered tests, and we are able to get item level responses that go into our data repository from that. And we have a whole map with that, and we can actually get data into the repository rather quickly, same day, which is nice. So briefly with the SHIP-NP, the nice thing is basically taking your neuropsychological interview. What we ask in our interviews, we ask a lot of the same things, right? We're all going to ask about cognition. We're going to want to know about medical history, psychiatric history with different lab results, psychosocial things. And this is really nice. And a lot of thought was put into this by Lucia Kavanaugh out of UCLA, who thought about different common data elements in neuropsych and how can we capture a lot of this in our clinical interviews that it can eventually go on to interface with EPIC. And UCLA has actually made a lot of progress in getting the SHIP-NP measure into EPIC. Currently, it is part of the NNN web portal, and people get sent out a link and patients will complete it if they choose to do so. And what happens is that the provider will get an alert that the SHIP-NP has been completed and it's totally de-identified. We use pseudo GUIDs, and we can go into the system, easily get the interview, and I'll go into what it actually can look like in a second. But some of the common data elements were leveraged with the Phoenix toolkit, looking at other NINDS common data elements, looking at DSM cross-cutting measures, and it uses smart logic to where if someone isn't endorsing emotional symptoms, well, then they're not necessarily going to be getting these questionnaires. So we don't want to keep having someone, fill out a lot of questions that are redundant if it's not relevant to them. So it will use some branching logic with that to make sure that it is not overly burdensome. Except for if you're an over-reporter, then you'll probably be filling it out for quite some time. And we're actually working on ways to customize this clinical interview where providers can decide which elements that they want, like out of the SHIP-NP, and they can have their own interview form that gets sent out. We're kind of working through which data elements that we want to make mandatory, and then other ones that will be more optional. What it does is people will fill out this questionnaire, and you can't put any identifiable information in it, and you can get a couple of reports. So the one that I use, which is extremely useful, is a narrative report. It is basically your neuropsychological interview in narrative form, which is so easy, and you can easily put that into EPIC. And then if you like more tables, then you can also get a tabular form as well. And you can see the different questionnaires that someone gets. You can get raw data output from those, but you can also get them in table format for summary data. So it really makes it easier. It shortens your clinical interview. It allows you to be able to ask questions that maybe you would like to do more of a deep dive into with your patients, but then you're trying to get through your hour clinical interview or maybe less than that so people can get through testing. In our clinic, I know at MCW, we really like to do same day feedback. So we want to try to be as efficient as possible. So this is something that I think we have now in over 22 clinics. So this is something that absolutely can be set up at different sites. And across our NNN sites, we have different methods on how we send out links to our patients. And in the future, like I was saying, this could be something that goes through like my chart through EPIC, which will be really nice. And then the Sailor technology, this is something that literally was started from scratch for this project. So it takes quite some time to build the software. The programmer who's been instrumental in getting the different tests up and running, and then also working with other test publishers, because certain test publishers are going to want you to pay for their product, and they're not really necessarily supportive of providing something free for research or scientific purposes. We have different measures that these are just some of them that we do have as part of this program, this web-based platform, and working on improving those. We will start to get ones that are in Spanish that are part of this, and then more novel measurements will also be able to be incorporated in the future, which would be nice if you think about different measures that are stuck in research and haven't really been translated into clinical practice. That, you know, if you join the NNN and as it becomes more international, then how great it would be to where some people might want to start collecting maybe like 10 normal controls or something across sites. That's not so burdensome if we have a lot of participation. So making it more collaborative, a collective effort. So for phase one, we've had a great success, especially with getting, creating a standard for item level data capture. It enables widespread data aggregation of routinely collected neuropsych assessments, part of our clinical practice. And as we expand to new sites, hopefully go international at some point, then it will hopefully serve as a model for future neuropsych research collaboration with a very much a clinical focus. And we hope that the infrastructure will help facilitate, foster and propel future projects that establish concurrent and incremental validity of different novel measurements or measures that have been well validated in research but have not been translated into clinical care. So in phase two, which we submitted a renewal and it was awarded, and the funding started actually, I think February of this year was the official start date. And we really, really wanted to make what we do relevant to underrepresented groups. And so part of that is, putting additional clinics who serve Hispanic or Latino individuals, Black or African American, and as we keep growing and trying to expand other underrepresented groups as well. And also building an infrastructure to enable assessments, in particular what's in the SHIP&P and Sailor, to be conducted in Spanish, and then future direction obviously would be other languages. And we wanted to interface better with electronic health records. And so we're coming to the mindset of what can we do, what different variables in EPIC, like social determinants of health, how can we maybe harmonize with what we've built through the SHIP&P with what's in EPIC, and how can we maybe improve what's in our EPIC system so we're capturing variables that we know are so relevant to consider when we're interpreting our neuropsych data. But right now our norms are very problematic in terms of SDOH capture and how we can incorporate that. And there's a lot of the race-based norms, and obviously that's been problematic for a variety of reasons and something we need to change. So the more that we can make this easy to do in EPIC medical records or other medical records, then this is going to be easier for it to be relevant for other clinicians, not necessarily neuropsychologists, but for other neuropsychologists. And also thinking about how can we use our data summary sheets. So a lot of people have homegrown data summary sheets that they're using. And how can we make sure that we're able to put something into the EPIC system that is searchable, and how can we get data out of EPIC that automatically populates a database versus trying to have like our own variables and our own definitions. And so trying to harmonize this across sites. One thing that we've learned with EPIC is they have a library. So if one site has this library of something they built, say the SHIP&P, and then they can share that library with other sites, and hopefully they will do so without trying to get lots of money. So the last aim for the renewal project is, to continue what we were doing in phase one we want to further characterize neuropsych constructs and efficient measurement methods, but now examine measurement and variance across racial and ethnic groups, including important covariates like acculturation, bilingualism, language proficiency, etc. And we want to, we further aim to identify optimal methods to distinguish different diagnostic outcomes and create neuropsych performance estimates based on key demographics and SDOH variables that can supplement our current very outdated norm-based strategies. And applying different novel psychometric methods to help with further validate what we do, and trying to address other issues with inequity in our assessments. So we think about the Boston naming test, for example. It's just, it's a terrible, it's something that's been used for a very long time, very old. And, there's other measures that we're using, that there may be just some kind of like bedside assessments, and we can do so much better with our measurement of language, for example, but then trying to get a sense of, is it actually assessing language across cultures? And so we can do so much better. And beyond the NNN R01 projects, like I was kind of alluding to before, we want to include other languages. We want novel test development and validation of measures that haven't been incorporated into clinical care. And we want our network, we hope, can serve as a model for international development and collaborations. Kind of like an ideal long-term goal is to have a global bank of methods to be shared freely, used to expand access to high-quality neuropsychological services and reduce health disparities and increase knowledge about human health and disease in the broadest sense. So we've talked a lot about at our different team meetings for the different PIs and other co-investigators about how can we possibly make sure that we are prioritizing where things are freely available, and that we are, don't become part of something that tries to profit off this. We want to make sure that this is benefiting neuropsychologists across the globe. So through this NNN project, in conversations with Bob Builder and other PIs, and where SIGS is part of the International Neuropsych Society started just growing over time, it was important to us to say, okay, what can we do with INS to try to expand what we are currently doing, allowing people who might be interested, like, hey, we have this here, leverage what we already have through the NNN, but also other people who are routinely just collecting neuropsychological data, and it just sits there in their clinics and it's their own special database, or other groups who are collecting it and it's easier to share across sites. So how can we start to grow and look at data across sites and not just kind of keep it in our own clinics, because it's critical that data sharing happens, and that we try to harmonize efforts to the best that we can without trying to tell someone that they have to give a different test, right? Because people like to give the test that they like to give. So some short-term goals is we want to grow our membership. We, there's been some issues with getting webinar series with the timing that INS requires. So hopefully that will improve over time. And we really want to grow membership across our members, or grow research collaboration, across our members, different cross SIG collaborations, in which we've started to do more and more, and forming working groups to foster data sharing and harmonization. We actually had our first working group meeting at INS in New York, which, interestingly, not surprisingly, kind of came into like, well, what can we do for a larger scale research collaboration? That's going to unfold over time and have different focus areas, and we hope for more participation in different aspects of that. So the long-term goals for this SIG is to leverage the NNN infrastructure to encourage global harmonization and data collection and open data sharing without disrupting clinical workflows, and foster international collaborations in the development of both universal and culturally appropriate neuropsychological measures. So we have, let's just go quickly reviewing our officers, and I'm getting past time. But we are going to be recruiting new officers for people who are interested. And we want students, we want trainees, we want faculty practicing. We wanted people outside of the US, outside of North America. And we would like to improve that. And here are student officers, and Raphael just recently joined us, so he'll be hanging around as the new cadre of officers come on board. We did collaborate with the INS Science Committee and Global Engagement Committee. And I don't know if you can see this well, but these were respondents who said, yes, they would be willing to be contacted by the Science Committee or by the WinSig to talk about developing different methods for research collaboration for data harmonization. And so we're getting a list of that. We're trying to grow that list. And then we hope as our SIG, from our SIG perspective, that we can reach out to people that are not just necessarily INS members. And hopefully we get the support from INS to do so. And this is the language in which respondents administer tests. So they're asking about common test usage. And obviously English is the biggest one. We were overrepresented by people in the US, but there are bilingual individuals as well as other individuals who speak some like, I mean, you can see like one across a lot of different languages. So that needs to improve. And as we get a better sense of regional representatives who will be collaborating with us. And these are some data from that INS Connect survey that just looks, and we tried to break it up the best we could by region in terms of the number of people who are administering different types of tests. And so we broke this up by domain. And so you can see a lot of Wechsler scales are used in different regions and have been interpreted in different languages. And here's some stuff with executive functioning tests used by region. And here's some memory tests used by region. And some of these are open source. You don't have to pay for them and are used quite often in different areas. Here's some language test, ENT being the greatest. There is an other category, and because we're trying to go through those data and get a sense of what if there's some commonly administered other tests in different regions, but we would like to have better representation from other regions to have a more robust understanding of things. And different mood symptoms across regions as well. The overall goal of the SIG is to facilitate advances in neuropsych measurement and analysis via international data sharing and harmonization, so much broader scope. So we're growing in membership, we're growing in our collaborations, and we hope that people join and are excited about these efforts, or even if it's students who are just like, I don't know what to do, but I would be so excited to participate in a project. Maybe I have this skill set and I've learned, I can do some IRT methods. We also want to build a student-led training series that will teach modern psychometric analytic methods. So we're working on that. And then also expanding and sharing the NNN technologies with other interested sites. And we've had requests to use some of the data that have been collected through NNN from external sites. And we just kind of chat about it as a group and see if we're in favor. And so we're not to that step where we have like any data use agreements or anything. So, and we haven't necessarily thought through that at this moment, just because it's just kind of been more of an open discussion. So if you are interested in becoming an officer, you're excited about, harmonizing data and improving our measurements, please join our SIG, please become an officer, because we want this to continue in a big way. So, sorry if I talk too quickly. Any questions? Here's the NNN website, and then that will just kind of update you with what's going on. And then the WinSig, that would be the email address, and you can also get that from the INS SIG webpage. Thank you.
Awesome. Thank you. Thank you to both Dr. McDonald and Dr. Umfleet for providing such a wonderful presentation, as well as providing opportunity for students and graduate students to be a part of such an ongoing project and get some more experience and become some change makers. For our audience, I just want to remind you very quickly that we will be having another presentation on April 15th. If you would like to come, we very much encourage you to join us. And I hope you all have a great rest of your day.